Hello, everyone. How many of you have heard of block? Okay. How many of you have heard of square? All right, way more hands. Okay. So block is the parent company from Square. A lot of people missed that memo, but you'll get context about what I'm talking about. So today I'm going to cover how we let AI speak fintech by making our Square APIs AI friendly. So I'm Angie Jones, I'm head of developer relations at Block, and my team support AI enablement and adoption across the entire company. And we're also training our engineers on how to build agent-friendly APIs, right? As well as teaching everyone in the company how to use things like AI agents to work more efficiently. So there's been a lot of talk about agentic AI over the last several months, and that's because this is where we really start to see benefit from AI. And one way we're seeing this is specifically with AI agents. So an AI agent is a system that takes action on your behalf. So think of your AI chatbots like ChatGPT, for example. They're conversational, right? They tell you how to do something. Well, AI agents, they take that a step further by actually doing the thing. So they can make API calls, they can generate and execute code, and they're able to trigger other actions as well. So the way agents are able to accomplish this is simple. Give them more context, right? Because chatbots like ChatGPT are not connected to your systems, to your knowledge bases, they're unable to perform the action. So that's why they tell you how to do it, right? But if you were to give your chatbot access to your application so that it has that additional context, it can do a whole lot more, especially when you're using an LLM that is capable of calling functions. Everybody familiar with an LLM? Okay, good, I don't gotta cover that. All right. So the de facto way to do this now is with MCP. Familiarity with MCP? All right, a little bit. It's brand new. Don't feel like you're late to the party or anything. So MCP stands for a Model Context Protocol. It's an open standard, just was launched in November 2024 by Anthropic, and it lets AI agents talk to different APIs, different tools, different data sources in this clean and consistent way. So you can think of it like a universal adapter. So instead of needing to custom code every integration that you would want your agent to connect to, you can just plug in these little things called MCP servers, and they're basically wrappers around APIs or tools or things like that, and the agent just knows how to interact with them. So here I'm using our open source AI agent Goose with the Square MCP server to get a seller's monthly revenue. And while all of that happened super fast, there was quite a lot going on in the background. So I want to show you the agentic loop of something like that. So we have a user, which could be a customer. We have an agent, which is an MCP client like Goose. So we talked about servers. The agents themselves would be the clients. And MCP clients like Goose, they take actions using installed MCP servers that you have. And then we have the LLM, which makes the decisions, okay? So all three of these actors are going to engage in a conversation until they are able to complete the user's requests, right? And this conversation is what's known as an agentic loop. So the first user gives the agent a natural language prompt, like asking Goose to get the total revenue from Square orders last month. That agent is then going to share that prompt with the LLM along with a list of tools that it has available. So tools, if you take nothing else from this talk, tools are one of the most important aspects of agentic AI because this is what enables the agent to actually interact with external APIs and execute actions. So the tools themselves, essentially just functions that interface with API endpoints, for example. So the full tool definitions are shared with the LLM. That includes the names of the tools, the descriptions of the tools, as well as the parameters that they accept. So based on the user's request and the tools that it received, the LLM is then going to reason that in order to get the revenue for the orders, I'm going to first need to get the list of available methods in the orders service, right? And so it tells the agent to call get service info function on the order service. So it shares that information with the agent, and this completes a full turn of the agentic loop. So a turn is a single cycle of reasoning and decision making. However, the problem is not yet solved, right? So another turn must take place. For turn 2, the agent takes the suggestion that the LLM provided, and then it makes an actual call to the MCP server. It receives the response, which is a list of available order methods and their descriptions. This is all formatted in JSON. LLMs love formatted data. And it sends that JSON back to the LLM along with the original context. Once the LLM sees the available methods, it uses that information to decide, okay, what's my next move, right? And it spots that list orders, but it needs the input schema for this. So it tells the agent, hey, call the get type info tool for me, and let's get that method. So the agent makes the call and receives a JSON structure that describes like the input schema for list orders. And then it sends those results back to the LLM. Now the LLM has enough context to figure out, okay, I know how to make the request to the API. So it lets the agent know how to do this. If you were using just a regular AI chatbot, the LLM will be giving you the instructions on how to do this, but here the agent is in the middle receiving those instructions and has the power to actually execute those instructions on your behalf. So the agent makes the API call, it sends the LLM the list of orders, the LLM parses the orders, it extracts the amount from each order, adds them all up, sends that result back to the agent, who then sends that message to the user, right? So now the user's task is completed, and this ends the agentic loop. Now, not all MCP servers are designed this way. In fact, many of them have tools defined for every endpoint that their API has. We found this to be way too much. So Square has more than 30 APIs with over 200 endpoints. So if we created a tool for every single endpoint, our MCP server would be bloated really fast, right? And that's a problem for a couple of reasons. So first, too many tools is going to slow your LLM down, right? Imagine if you walked into somebody's kitchen and you came over to cook them a meal, right? And they say, you say, hey, where's your pots or whatever? And they pull out like every pot they have, every utensil, every like appliance, and sit it all on the counter. You're going to spend half of your time trying to figure out, like, what am I supposed to use here, right? So you're slowing the LLM down by doing that. If your server exposes something like 200 tools and then you ask for total revenue, it's going to evaluate all 200 tools, guess what, on every single turn. And that's not just your server, right? In reality, users are going to have multiple servers enabled. Like, I want to be able to mix and match like 3 or 4 different servers to really do something interesting. But now your 200 tools are mixed with somebody else's 200 tools, and it just becomes a lot. The tools are namespaced with the server, but a key thing to remember is that LLMs are stateless, right? So even if I chose the right tool on the first turn, when you come back to me and ask me a follow-up question, I don't even know who you are. What are you talking about, right? So you have to pass all of that context in with every single turn, right? And so that's going to help. I mean, it's going to hurt them. It's going to, even if there's two things that like look familiar, it might have called this one this time and then a whole nother MCP server the next time, right? And so it could pick the wrong one. And remember, all of this overhead adds up, not just in the decision making, but your memory usage, right? So again, the LLM needs to carry those tool definitions forward with every single message just to stay grounded in what's happening. And once the context window, so the context window, I like to describe this as like a notebook sheet of paper. If you're writing something down, like say a conversation, once you get to the end of the sheet of paper, what do? You need to flip over to the next sheet to keep going. Well, everything that's on that other page, is not in your view. You've kind of forgotten. And that happens with LLMs as well, based on the context window. So if you got 200 tools and you're filling that up every time, you're filling up the context window, and things start to break down really quickly when that happens. So every tool definition, including its name, its description, its schema, is taking up valuable space in that context window. So the more tools you expose, the more tokens you're burning too for your customers. And this is before the model even starts reasoning or anything. Once you hit that token limit, again, the model's going to start forgetting messages. It might just kind of stop the session altogether. So for the Square MCP server, we surface our 200 endpoints with only 3 tools. Gasp. So we have the get service info, the get type info, and then make API requests. So we developed it in what we're calling the layered tool pattern. All right, and this breaks MCP tools into distinct functional layers that work together. So this creates a more structured approach that's going to guide the LLM through the progressive steps like we saw in that example. And we think of the server tools like a team that's kind of working together, where the discovery tools are going to help the agent figure out what it can do. The planning tools will help it figure out how to do it, and then the execution tools actually do the thing. And this pattern is reusable across domains, okay? It makes your server way more agent-friendly. So the discovery layer, this is the entry point into the MCP server. This is going to help the agent understand what it can do before it tries to do anything. And trust me, you want it to know what it can do. Otherwise, it's just going to start trying stuff, right? So we have our Get Service Info tool, which provides this high-level map of available operations. Think of it like a table of contents so that the agent doesn't have to guess. Because it will guess. It will hallucinate some things, right? You've seen it. Think of this like onboarding your LLM, where you're saying, here's what I can help you with, here's the shape of my data, and here's where you should look, right? And notice this tool description here. So this is information for the LLM. This is not for human beings, right? And the LLM is going to read the description of each tool and determine, does this seem like it should be used to solve whatever task that I'm trying to solve, right? So for this one, we explicitly tell the LLM, hey, this is how to get information about the Square API, and this should be called before you try to get any type information. This is short and sweet. For your descriptions, you definitely want to be clear, but don't make it too long. Why don't we want to make it too long? I said it 3 times. Tokens and context exactly. So if it's too long, again, that's going to be repeated over and over in the conversation to the LLM. So you don't want it like too long. All right. And then the parameter here is the service. So you're asking the agent to let you know what service it wants information about. Now, Once the agent knows what services are available, it moves on into the planning layer. So this is where it figures out how to perform the task. And the tool here is get type info, and this gives the agent the details it needs to form like a valid API request, such as what parameters are required, what data types should I expect, and so on, right? It's like checking the recipe before you start cooking. You know what you want to make, now you need the ingredients, you need the instructions. We also use the tool description here to guide the flow, if you've noticed, right? So this is saying you must call this before calling the Make API request tool. So this is nudging the agent to plan ahead instead of skipping straight to the execution, because they really want to get stuff done. They're very incentivized to get stuff done for you, and a lot of times they'll just jump right to that. So you want to say, hey, before you do anything, let me tell you how to go about getting the information you need. You'll also notice that we ask for both the service and the method here as parameters. And so this is going to give the agent enough context to pull the exact schema that it needs. Now, the agent knows what it wants to do. It knows how to do it. Now you say, okay, now you can play. You're ready to take some action. So this is the execution layer. And it makes use of the Make API request tool. And this is a unified tool here that can handle any Square API call. So it can create a catalog item. It could list payments. It could fetch customer data, you name it. But notice the first line of that description. Be sure to get types before calling. Again, this is not a reminder, this is a constraint, right? We're enforcing that pattern of discover, plan, and then execute. Okay, for the parameters, the agent needs to supply the service, the method, and optionally a request payload. And because we've already run get type info, the agent now knows exactly what that request should look like. So this layer is all about doing the thing, right? But you want to do it with precision, right? Based on that prep work from the earlier layers. And the discovery and the planning layers, they do introduce extra steps for the agent, but we thought that this was a risk worth taking. Working in high-stakes domains like fintech, this is a trade-off we're willing to make, right? Because accuracy matters more than just shaving off a couple of milliseconds. And you saw it wasn't slow, you saw it in action, but it could be faster if we didn't have these layers, but it also could make mistakes. So you've seen how the agent interacts with the layered MCP server, but where does it get all of the knowledge from, right? So the MCP server doesn't call out to open API. It doesn't try to infer the request shapes on the fly. Everything that the agent knows about Square's APIs, every method, every parameter, every type, is actually hard-coded in the repo. So each service, like catalog, for example, defines its available methods. And these entries tell the server everything that it needs to know, like the HTTP method, the path, the expected parameters, the request type, and whether it's a write operation. And then there's this type map that we also have in there, which defines what goes inside of the request. So each request type is going to list the fields, the types, the descriptions, just like an internal schema. So when the agent says, I want to call list catalog items with cursor and types, that's not a guess, right? It already knows those are valid and that they belong in the query string. So initially, this feels like a bit of a smell. Like sometimes I still kind of put my nose up when I look at it, like hard coding the API surface within the server itself. But this design gives you a predictable, testable interface that only exposes what you actually intend to support, right? And because the method and the type definitions are versioned in code, they're going to follow that same review and CI processes as everything else. Bonus is that this also keeps your attack surface minimal, right? The trade-off, of course, is that when Square's APIs changes, then yes, we do need to come back and update these files, but that also means that we never expose any new endpoint accidentally, right, before we're ready for an agent to interact with it. But overall, this is really clean, safe design. It gives you that same rigor around agent behavior that you would expect from like any secure production system. So every tool call in our MCP server ultimately flows through a single function that routes the request to the appropriate Square API. And this is the centralized handler, and it's where we bake in our internal safety checks. This is giving us this consistent place to apply guardrails. So the function is the make API request, and remember, this is our tool that's on that execution layer. And this is the last checkpoint before the agent now has access to our system. So we utilize this checkpoint to do some really, great things, right? Our safety and our consistency logic. So it validates the service in the method names to make sure that the agent is not about to call something invalid and waste everybody's time. It routes the request to the appropriate handler for that selected API. It formats the response into a clean MCP compliant output that the LLM is going to be able to interpret. It checks for permissions using this disallow rights flag, and I'm going to talk more about that in a second. It also injects auth by automatically fetching the right token, and then if anything goes wrong, it returns a standard error structure with full context. That's really helpful. I'll tell you why in a bit. So this gives us a single reliable control point for safety, for debugging, right, without making the agent manage any of that complexity. So one of the most useful runtime guardrails that we've added is this simple flag, disallow rights. So when this is set, the centralized handler is going to block any request that's marked as right, like creating payments or updating inventory. So this lets us test our API like safely using an agent without risking like any real changes to our production data. It's also really useful in sandbox environments or when you want to do a little demo, but you don't want to actually let it do the thing. So here's an example of how the server responds when something goes wrong, like when the agent tries to call an invalid service or method, right? And I know that these look like simple validation checks, but let's really look closer. This is carrying a lot of weight in the agentic system. So we often talk about developer experience or DX, right? Now we also have to consider AX, agent experience. So instead of just saying invalid method, now the server provides a list of the valid methods, right? That small touch is making a big difference because it's giving the agent a chance to recover, correct that mistake, and then keep working without a human needing to intervene. Now, once you give the agent the ability to take these real actions, especially across our sensitive systems like payments, customer data, inventory, safety and security become non-negotiable. Amen? Amen. So I want to share some best practices for developing MCP servers from our InfoSec team who has gotten deeply involved when they saw the kind of stuff we were doing. And they had a lot of opinions. So agents are non-deterministic clients. That means you can't assume that they're always going to behave as expected, right? Treat them like untrusted users. That means you should enforce authentication. You need to validate their input. You need to reject unknown tools or methods that they're trying to use. You can use those simple flags like the disallow rights in your lower risk environments, but you also want to think about things like role-based access. You want to think about scoping tokens, audit trails for your production use cases. Some data should never leave your machine, right? Especially if you're talking to like a third-party LLM. So you want to implement some like maybe model level allow list. You want to maybe redact some of the tool output when necessary. You can also annotate your tool. So MCP has this in the spec now where you can annotate a tool as read only or destructive. Destructive, that sounds really harsh, but it means it's going to change something on your system. That could be an edit, that could be a write, right? And all of this just enforces extra guardrails. And then an MCP server is proxying actions into your actual systems, right? So you want to secure that back-end connection just like you would any external API. And then many MCP servers are actually installed locally, believe it or not. This is the part that really freaked out our InfoSec teams. And so they're installed with things like MPX, for example. That's arbitrary code execution, like on your local system. So make sure like you sign your releases, you're maintaining a trusted source, and encourage your users also to validate what it is that they install. Speaking of which, when building an MCP server, you have two deployment options. So you have the local or you have the remote. So the local one, again, this is the one we just talked about. This one is running on your machine, and it's usually installed with a command like npx or uvx or something like that. And it's quick to spin up. Great for deployment, for development uses, but it uses a manually configured token, okay? Typically pulled from something like your environment variables. That means that full API access with whatever token is available, which is convenient, right? But this is not ideal for a shared or a production environment. The remote server, on the other hand, this one is hosted by the provider themselves of that MCP server. In our case, that would be Square. And this one is much more robust and great for production use cases, right? This is going to handle authentication through a secure OAuth flow. So customers would sign in with their Square account, and the system only grants scope access based on the permissions that you approve. So that makes it much safer, especially with that real user data. Square actually supports both of these options. So for developers that are experimenting locally, they're just trying to build a prototype, right? Maybe using this as a payment option within their app or something like that. The local server, that works just fine for those cases. But when they want to integrate this into their live systems or give access to other people, then they would switch over to that remote server to keep their data and their users protected, all right? It's also worth designing your MCP server for auditability. So routing tool calls through that centralized handler I talked about gave us this opportunity to log what the agent is doing and why, right? And that opens the door to better monitoring and debugging. So at a minimum, there's 3 things that's worth logging: what tools were called and with what inputs, especially the tool call request that the model sends. And then also, if anything went wrong, you want to log that, and you also want to know how the server responded to that. So this gives you a full picture of the agent's behavior from intent all the way through to outcome, right? And if you want to deeper traceability, you can also log some other things like the model reasoning can be logged, the prompt traces can be logged, and that's especially useful for debugging like any odd behavior or detecting misuse, okay? So this type of traceability is essential in high stakes domains, right? If something goes wrong, you don't just want to know that it happened, you also want to know why that happens so that you can fix it up. All right, so to wrap up, here are a few lessons that we've learned that might help guide your own journey. You don't need to rebuild your product to make it agent friendly, okay? Start wrapping what you already have, but you just want to do that really intentionally, okay? Think in terms of tasks versus in terms of endpoints. okay? Even if you don't use the layer tool pattern, still when you design your functions or your tools within your MCP server, think about like what are the scenarios you're trying to support versus just listing all of your endpoints, right? A tool like our Get Service Info can extract basically dozens of backend calls. And the key is to make it easy for your agents to reason and then succeed. You also want to avoid flooding the LLM with hundreds of these low-level tools, right? Instead, layer your design. Start with those high-level helpers that kind of guide the agent, and then delegate that stuff to your deeper tools behind the scenes. In domains like fintech, it's really good if the agent takes a couple of extra milliseconds to get it right, you know, versus hallucinating someone's bank balance, for example. We're optimizing here for that correctness, not that speed. And then security just absolutely cannot be an afterthought. I'm going to be very honest with you. MCP, like I said, is relatively new, came out in November. It's kind of the Wild Wild West. I'm going to take one wild off. It was the Wild Wild West. The spec has improved. You know, we've kind of deprecated some of the approaches and added new ones to make it more secure. So not Wild Wild West, but Wild West right now. All right. So you have to like I would bring in the security people. We kind of let them sit next to us now while we build these MCP servers, right? Your server should never assume trust. All right. Enforce scopes. Separate your read tools from your write tools. Make sure that your auth model is reflecting the granularity of your APIs. If a human wouldn't get access to something without signing in, your agent definitely should not either, okay? And then LLMs, they thrive on structure, so don't make them guess what the next step is, right? Give them the workflows. Keep the spaghetti at home, break your tools up into predictable shapes. Always great to provide some examples to them, and where possible, you want to encode some patterns into your APIs so that the agent doesn't have to invent them, because it will if you did not specify. The other thing is just know that things are going to go wrong. All right, you need to accept that. You need to know that going in. So build with that in mind. That's why you want to log every tool call, every input, output, failure, what happens, right? Return those useful errors so that you can help the agent actually recover. All right. So I hope that this was helpful. Can I answer any questions for you all? Yes.
Yeah. I can get the discover part and then the execute part, and actually the plan part. Have you got? Oh. So I get the discover part and the execute part, but how do you do the plan part in terms of how do you actually help the agents be able to plan what they're going to do? And what APIs to use? I think I just saw it on like one line, but have you got an API behind that helps them plan? How are they getting that data back for what APIs they might need to call?
Yeah. So that one is where you're like getting that type info, and remember like that's where this kind of code structure that we hard code into the server comes in really helpful. So now I know what's available. Now I need to plan what I'm going to use. And now that I have that data, I'm able to kind of pull exactly what I want, get the schemas, Now I know exactly how to call the API. That's when you go into the execution phase. So the first one was just, here's everything I have, right? Table of contents, if you will. Planning is like, okay, I'm going to grab this and this, put that together. All right, that makes sense. Yes, let's do it. And then you move to execution. Did that make sense?
I'll come talk to you after.
Okay.
So you talked about AI experience and developer experience. I kind of heard like, if we made our developer docs really, really good, then AIs could understand them. So do we need two sets of docs, or should we just assume our developers and our AI need more help than we give them.
Okay, I got a spicy take. Nobody reads the docs, right? Except the agents. So you might as well write them for your reader, which is the agents. And so what I've done actually for Goose, we have like a lot of docs. Nobody reads them. They're always asking us questions that's right in the docs, right? So we made an MCP server with the docs. And now you can just put that right in Goose, and then you can just ask Goose a question about how it works or what you want to do, and it'll read the docs for you. So I'm really big and I have nothing but love for docs writers. The docs team reports to me. So that's one of their goals for this year is go make all of our doc sets AI consumable. Like make it easy for the agents, and by doing that, my theory is that you make it easy for the developers, because now I don't have to read through your docs. I can just write a natural language prompt to any AI agent, and it'll tell me exactly how to do the thing.
How do you get buy-off from risk and compliance when you can't guarantee no hallucinations in the result?
Yeah. So I don't know about you all's company. I imagine like you probably are seeing some of the same trends where it's like, no, we're doing this AI thing, right? And if we don't, we're going to get left behind. So figure it out. Here's what we're doing, and you go figure out how do we make this safe and less risky, right? And so that's kind of been the mandate that I've seen, not just in our company, but in lots of different companies where they just have to get on board. And like even our InfoSec team, it's like, nope, we're doing this. And they're like, wait, it's the Wild Wild West. And we say, well, figure out how to get one of those wilds off of there because we're doing it, you know? And then they jump in and they figure out how to make that better. I don't know what it is that they do. They do it, you know, behind the scenes. But yeah, their eyebrows go up for sure. What other questions can I answer? Okay, great. Well, thank you all so much for your time. If you have any other questions, I'll be outside. Thank you.